Welcome back to educator.com. For the next lesson, we're going to go over similar polygons. Okay, so polygons, we know, is some kind of shape. So if you have a triangle, triangles are polygons, squares, rectangles. Okay, those are all considered polygons. Now, similar polygons means you have two polygons with the same shape. They have to look exactly the same, but they're just different sizes. So one's going to be smaller or bigger than the other one, but then they have to have the same exact shape. Okay? So when they're similar, it's a little symbol like this. This means that this triangle here is similar to this triangle here. It means that they have the exact same shape. It means that one is not going to be any fatter and less taller and all that. It's going to have the exact same shape, but it's just going to be different sizes. Okay? So an example of similarity. Similar, so if you're a baby, right? When you're a baby, you have small hands, you have small feet, right? You have, you're small. As you get older, you grow, right? But everything has to grow proportionally. Your hands grow and your feet grow the same amount. So if you're a baby and everything is small, as you grow older, it's not like only your feet are going to grow, but your hands stay the same size, right? So everything has to grow according to how big and small or different, let's say, sizes, but then you're still going to have the same shape. So that's kind of an example of what it means to be similar. Okay, everything is proportional when things are similar. So again, if this is going to grow, if it's going to grow taller, then it also has to grow wider. It has to grow in all areas, just like a baby grows in all areas, right? So again, same shape but different size. Then the corresponding sides are proportional. Corresponding just means that the side that's basically related to each other. So this side and this side are called corresponding sides. Okay, corresponding sides. It means that this side and this side are like the same. Okay, they're being compared to each other. Same thing here. This side with this side, and this long side with this long side, right? So they're all corresponding. Okay, so that means I can create a ratio for each of these corresponding sides. That means I can compare this one with this one. So 4 to 6, remember that's a ratio. And then it's all proportional. Proportional means that this ratio is going to equal, if I make a ratio for this, that's going to be the same. And then for the third side too. This ratio to this is also going to be the same. So just saying that all the sides, if you compare this side to this side, that ratio is going to be the same as this side to this side, and it's also going to be the same as this side to this side. So we have 3 ratios. We only need 2 to make a proportion, right? So if you have a triangle, you're going to have 3 different ratios, but you only need 2. So you're only going to use the sides that, they give you measures for. And then you can create a proportion to solve for the missing side. Okay? So see how this all equals each other? 4 over 6 is equal to 4 over 6. It's also equal to 6 over 9 because they all equal the same ratio of 2 over 3. Okay? All of these ratios equal 2 over 3. So that means these are all the same. Okay. So the first example is these 2 similar triangles. So you can draw a little similar symbol like that. That means this triangle and this triangle have the same shape, but just different size. Okay? That means I can write a proportion and then find the value of x. Now, here, this side is corresponding with this side, right? So I can create a ratio comparing this to this. So the ratio will be 5 to x. And again, I want to write my ratio as a fraction because that's how I'm going to solve my proportion, right? So this side to this side is 5 to x. That means I can also create a ratio from this side to this side. That'll be 2 to 4. Now be careful. If you're going to make a ratio of this to this, then for the next ratio, the top number has to be from the same triangle. So if it's going to be this to this, then you have to make the next ratio this to that. Okay? If you switch it around, then it's not going to be the same. It's like saying boys to girls equals girls to boys, right? You're flipping them. You're changing them. So you can't do that. So if it's this triangle to that triangle, then your next ratio has to also be from this triangle to that triangle. So then to solve this, you can use cross products. Remember, cross products is when you multiply across. Or you can just simplify it and then use just mental math. So here, 2 over 4, this is the same as 1/2. Now how do I know? 2 divided by 2 is 1. 4 divided by 2 is 2. So then I can just make this also equal to 1/2. Well, 1 over 2, that means the bottom number has to be double the top number. So then 5 over what? What is x going to be? Well, if you multiply this by 5, you're going to get 5. So you have to multiply this by 5, and you're going to get 10. So x has to equal 10. That means this side has a measure of 10. Okay, same thing here. We're going to write a proportion to find the value of x. So here I can say this to this over or equal to this side to this side, right? Or if I want, I can start off with this rectangle first, as long as I stick to it for my second ratio. So 5 corresponding side is x. So 5 over x equals, stick with the same one first, 7 over 14. Okay, you can write it like that, or you can start with this one first. Doesn't matter, as long as you stick to that order. So 7 over 14 is 1/2, because 7 divided by 7 is 1. 14 divided by 7 is 2. Okay, that means I need to turn this also into 1/2. So 1 times 5 is 5. 2 times 5 is 10. So then x is going to equal 10. Okay, if you want to practice cross products, again, you're going to just do 5 times 14, which is going to be equal to x times 7. So I can write 7 times x. Okay, and then you're going to just solve that out and then divide the 7. Okay, and you're going to solve for x that way, and you're still going to get 10. Okay, 70. 7 times 10 is going to equal 70. For the third example, this is called a parallelogram. Okay, it's not a rectangle because it's not perfectly going straight up and straight across, so it's not perpendicular. It's kind of tilting off to the side, right? So this is a parallelogram. But these are similar polygons. Here, this is corresponding with this side, right? And this is corresponding with this side. But they give you the other sides. For a parallelogram, this side and this side are the same. So I can just write this as 12. And this side and this side are the same, so this is going to be x. Okay, so when I write my proportion, I'm just going to do the same thing. So 6, ratio of this to this side is 6 to x, which is equal to 9 to 12. Okay, again, I can figure out an equivalent ratio. 9 over 12 is the same as, let's divide this by 3, divide this by 3. So 9 divided by 3 is 3 over 4. That means this also has to be the same as 3 over 4. 3 times 2 equals 6. So that means I have to multiply the 4 times 2. X is going to give you 8. That means this side right here is 8. Okay, again, you can just do cross product. 6 times 12 equals 9 times x. Okay, and solve it that way. Okay, for the fourth example, they give us a word problem, and then we have to draw our own similar polygons. So, a tree casts a shadow that is 10 feet long. So, let's see, I want to draw a tree. Okay, there's a tree. I know my drawing is kind of bad. There's the ground. Tree. Okay. The shadow, let's say this is a shadow, is 10 feet long. So this is 10 feet. A person 5 feet tall is standing next to the tree. So let's say the person is right here. Draw a stick man. Okay, this is still the same ground. Person 5 feet tall is standing next to the tree and is casting a shadow, or let's say this person is 5 feet tall. So from here down to the ground is 5 feet. So where this person is standing, his shadow is 3 feet, right? The triangle formed by the person's height and the shadow, that means height and shadow, this is a triangle, if you can see that. Okay, this triangle is similar to the tree and its shadow. So then the triangle formed by this tree. So here, all the way down to the shadow. So these two triangles, this triangle here and this triangle here, are similar. So they want us to find, what is it? The height of the tree. So how tall is the tree? That I'm going to make this x, right? From here to here. So then because they said it's similar, I can make a proportion now, right? So I can say the 10 feet, the shadow, over the 3, right? Because this side is corresponding to this side. It's going to be equal to the tree's height. Remember, if you started off with this tree triangle, then you have to start it for the next one, right? So the tree height, x, over the person's height, 5. Okay, so from here now it's a proportion. Now I can just solve it out. So in this case, I can't simplify this. I can't do the equivalent fraction method because this is already simplified. There's no number that goes into both 10 and 3. So in this case, I just have to use cross products. So here, I'm going to do 3 times x. So 3 times x equals 10 times 5, which is 50, right? So again, if I'm going to solve for x, I need to divide this 3, okay, because 3 times x is 50. So it's 50 divided by 3 to find the x. If I want to find this, I have to do that. Make sure this top number goes inside. 3 goes into 5 one time. 3. If I subtract it, I get 2. 0. 3 goes into 20 6 times, which is 18. I get 2. Okay, now that I have a remainder, I have to put my decimal point, bring down another 0. 3 goes into 20 again, 8 times, so 18 again, 2, another 0, so 8. So it depends on how many decimal numbers after the decimal point your teacher wants. But otherwise, you can just probably leave it as 16.89 or maybe 16.9 if we're going to round this. Okay, round this from that number, 16.9, and then that will be in 8. Okay, so the X or the tree is 16.9, almost 17 feet tall. Okay, so again, create your proportion. Make sure when you do your ratio, you're going to stick with the same side first. So it's this side to this side is your ratio, equals this side to that side. Okay, ratio. And then you just solve your proportion using cross products. Okay, so that's it for this lesson. Thank you for watching educator.com.